Good morning, kids. Today's class we are going to discuss the electrostatics one shot for JEE means. Every year they are asking one question in every paper, and if you look at the JEE advance, one or two, and it's like a some mixed concept. यहाँ से आप जो electrostatics आप पढ़ते हैं, इसका application आप capacitor, current density, electromagnetic induction, AC currents, बहुत सारे चैप्टर्स में इसका एप्लीकेशन हम इवन मॉडर्न फिजिक्स में हम यहाँ पे देख सकते हैं. सो दिस इज सम वेरी गुड कॉन्सेप्चुअल. ज़्यादा फॉर्मूलास हैं, कॉन्सेप्ट थोड़ा कम है, बट फॉर्मूलास बहुत ज़्यादा है. सो रिमेम्बरिंग फॉर्मूलास इज़ वेरी इंपॉर्टेंट. एंड कुछ बच्चे मेरे से ये पूछ रहे लेके सर हम वन शॉट हम लेके देख रहे सर, बस उससे हमें एग्ज़ाम में उतना बेनिफिट नहीं हो रहा है. यहाँ पे लेके watching okay you're watching one shot, then देखने से लेके 1 hour 2 hours आप देख रहे हैं वन शॉट, आप उससे रिकलेक्ट कर लो. और जो इलेक्ट्रोस्टैटिक्स इट इज ए ब्रीफ व्हाट इज वन शॉट, इट्स ए ब्रीफ रिवीजन. तो हम जो या मैं रिवाइज कर रहा हूँ, इससे आप कंप्लीट चैप्टर जो 10 या 20 घंटे का है चैप्टर है अराउंड 25 hours, the 25 hours chapter what happened I'm concluding in 1.5 hour. तो आपको वो जो कॉन्सेप्ट्स है वो आप टू रिकलेक्ट. कहाँ से रिकलेक्ट करना है? तो यू हैव टू रिकलेक्ट फ्रॉम टीचर नोट्स. आप जो टीचर क्लास में जब टीचर पढ़ा रहा है, आप जो नोट्स लिख चुके हैं ना, उस नोट से आप फिर जाके एक बार रीड कर लो. दैट इज कॉल्ड लाइक ए लर्निंग. जब आप पढ़ते हो, ये वीडियो देख लो, बाद में आप जाके नोट्स देख लो, बहुत सारे कंक्लूजन्स आपको सिस्टमेटिक हो जाएंगे. देन यू टू रिवाइज इट. एक दो तीन बार आप जब नोट्स को पढ़ोगे, देन ऑटोमेटिकली व्हाट हैपन, यू स्टार्ट रिमेंबरिंग फॉर्मूलाज, ऑल आइडियाज. देन उसके बाद जब आप पीवाईक्यू सॉल्व कर रहे हो, यू आर बीन कॉन्फिडेंट. ओके, दिस इज वन स्टेज वाइज. वॉच वन शॉट. मेरा नहीं, किसी का भी वन शॉट, but this is one methodology. One shot, watch videos. After one shot, take teacher notes, learn through teacher notes, then revise many times, then solve PYQ. So this is one stage wise like a preparation what we needed. Then once you solve PYQ, and as you are solving PYQ on your own, and you'll get confident and skills will develop. And यही जो आपको एग्जाम में यूज होता है. हार्डवर्क चाहिए, लेकिन बिना हार्डवर्क आप जैसे मूवी हम देख रहे हैं वैसे देखे हम लेकिन मैनेज करेंगे, नॉट पॉसिबल. ओके बच्चों, लेकिन दिस इज माय व्यू. ओके फाइन. सो विल स्टार्ट द electrostatics one shot. सो व्हाट आर द टॉपिक्स यहाँ पे? इलेक्ट्रोस्टैटिक्स एंड गॉस लॉ दोनों है. लाइक मैं इसको स्प्लिट कर रहा हूँ बिकॉज इलेक्ट्रोस्टैटिक्स एंड गॉस लॉ विल बिकम लेंदे. ओनली इलेक्ट्रोस्टैटिक्स यहाँ पे हम विदाउट गॉस लॉ. दिस इज next video will go for complete only Gauss law. So we are going to have the point charges. यहाँ पे point charges हैं. पॉइंट चार्ज के बारे में थोड़ा डिस्कस करेंगे. फिर कुलम्स लॉ, इलेक्ट्रिक फील्ड स्ट्रेंथ ड्यू टू पॉइंट चार्ज, देन लाइन्स ऑफ फोर्स, देन ई ड्यू टू वेरियस चार्ज बॉडीज. दिस अ फॉर्मूला बेस्ड. देन एफ इक्वल टू क्यू ई, वेरी इंपॉर्टेंट फॉर एग्जाम, दिस वन एप्लीकेशन वन, एफ इक्वल क्यू ई प्रॉब्लम. देन उसके बाद एनर्जी के बारे में, इलेक्ट्रोस्टैटिक फील्ड एनर्जी बारे में. देन पोटेंशियल, वाई पोटेंशियल किस लिए हम पढ़ना है, एंड व्हाट इज यूज ऑफ इट, एंड हाउ टू कैलकुलेट पोटेंशियल ड्यू टू वेरियस बॉडीज. देन बाद में field and potential का क्या relationship है, and then work done in moving charge in electric field. Then last we'll conclude with the electric dipole. Okay, this is what I'm going to summarize in this electrostatics. Gauss law अगले वीडियो में मैं अपडेट करता हूँ. Okay, fine. So हम यहाँ पे we'll start with the point charges. Point charge. So what is a point charge? Where the whole charge will be concentrated point. Point charge इतना छोटा, like 1 millicoulomb और a 10 coulombs. then even it can be 10 into, also like a 3 into 10 to the power of 4 coulombs. Point charge मतलब ये नहीं कि like इसका negligible charge. No, point charge can have any magnitude provided the total charge should be equal to n into e, where n is 1, 2, 3, 4 and so on. E is the charge of electron. Okay, like this we define the charge of a electric. And what are the properties of charge? Charge is conserved. यहाँ पे हम electrostatics properties, charge is conserved. Charge is quantized. Like charges repel, unlike charges attract each other. These are some properties are there. Then how do we produce charge? Next we'll go for the produce charge. Charge is produced by the friction, rubbing the bodies against each other. By conduction. Next, this is induction. These are the three processes in which we'll produce a charge. What do you mean by modern positive charge? Positive charge means deficiency of electrons. This is a modern definition. Negative charge को हम efficiency of electrons बोलते हैं. Okay, fine. So charge, our charges are produced. Then यहाँ पे glass rod है. जब हम rub करेंगे, there's a piece of silk cloth. Then the glass rod will get positive charged and the silk cloth will get negatively charged. यहाँ पे electrons कहाँ पे ज़्यादा यहाँ पे है, means the electrons will jump from glass rod to the silk rod. The reason for that, work function of glass rod is less than that of silk. That's why when we rub both the bodies, heat will be generated, that heat will be absorbed. Once that heat generated is greater than work function, then the electrons will leave the surface. When a body loses a charge, it will acquire positive charge. So glass rod will acquire positive charge. So the work function of glass rod should be less than that of silk. When you rub two bodies, then the charge body which will acquire positive charge, its work function will be less compared to the other charge body. So this is one basic idea. So this is about charge by friction. Then charge by conduction. यहाँ पे न्यूट्रल है, यहाँ पे मैं चार्ज कंडक्टिंग स्फीयर यहाँ पे लेके आ रहा हूँ. इससे पहले ये न्यूट्रल था. जब हम चार्ज कंडक्टिंग स्फीयर यहाँ पे लेके आते हैं ना, so when it is comes in contact, then some charge what happen will flow from rod to the sphere. Then I'll remove this charge rod. This will acquire a sphere. This is called like a conduction. Conduction, the two bodies will come in contact. Next, इसके बाद में like we are having the induction. Neutral sphere, यहाँ पे न्यूट्रल कंडक्टिंग स्फीयर है. सेम थिंग लाइक मैं यहाँ पे एक चार्जड रॉड लेके आया हूँ. लाइक यहाँ पे चार्ज रॉड, इट वाज न्यूट्रल. जब यहाँ पे चार्जड रॉड नजदीक लेके आता हूँ, सो इट विल इंड्यूस चार्जेस लाइक दिस. माइनस क्यू प्लस क्यू। बाद में इसको हम अर्थ करेंगे। दिस इज सम प्रोसेस वेयर यहाँ पे पॉजिटिव चार्ज है, इसको हम अर्थ करेंगे। जब आप अर्थ करेंगे, ऑल दिस पॉजिटिव चार्ज विल फ्लो टू द अर्थ। ओके फाइन, जो भी बचा है वो नेगेटिव चार्ज यहाँ पे। सो नो आई विल रिमूव द अर्थ एंड वो चार्ज ड्रॉप जब हम रिमूव करेंगे, ओनली यहाँ पे नेगेटिव चार्ज प्रेजेंट होगा। Same iron ball. This is called like induction. In induction, the bodies will not be in contact. In conduction, the bodies will be in contact. यहाँ पे आप देख रहे हैं, rod will be in contact, and in friction also they'll be in contact. So there are three methods are there. Okay, fine. So अगला idea ले लेंगे। Next, Coulomb's law. If there are two charges are there, plus Q minus Q, the force of interaction between them plus Q2 Q1 is given by K Q1 Q2 by x square, where K is 1 by 4 pi epsilon naught. Epsilon naught is called as absolute permeability of free space. अगर यहाँ पे मीडियम है, like I just said that we are immersing in a medium, कौन सा तो लिक्विड ले लो। अगर यहाँ पे हम लिक्विड में इमर्स करें, then the force will be Q1 Q2 4 pi epsilon naught R x square, where epsilon R is called as relative permeability. So that definitely the force will decrease. अगर आप देखेंगे F dash will be less than F. Then we'll see the Coulomb's law. Same thing is in the vector form. We have two charges, Q1 Q2, vector form. Let me define the vector form. इसका पोजीशन वेक्टर होगा R1, इसका पोजीशन वेक्टर होगा R2। Then how to define? यहाँ पे फोर्स तो मैग्नीट्यूड F ही है। कौन सा तो एक F12 F21, वी कैन डिफाइन आइदर वन। यहाँ पे मैं F12 डिफाइन कर रहा हूँ। F12 इसका मैग्नीट्यूड कितना है? K Q1 Q2 बाई R स्क्वायर। देन इन द वेक्टर फॉर्म F12 इज इक्वल टू F12 R कैप K Q1 Q2 R square, R cap का will be R bar by R. So K Q1 Q2 R cube by R bar. So what is R bar vector? R bar vector हम यहाँ पे इस तरह डिफाइन कर रहे हैं, R bar. Then R2 bar plus R bar minus R1 bar equal to 0. R bar equal to R1 bar plus R2 bar. R1 bar minus R2 bar. K Q1 Q2 by R1 bar minus R2 bar whole cube R1 bar minus R2 bar. This is F12 bar. Okay, this is a F21 bar. So F21 bar will be minus of F21 bar. Now remember this formula, very useful. So ये जो formula है, so this is based on in the vector form of Coulomb's law. This Coulomb's law will obey the superposition principle. Force of interaction F31, F13, F21, F12, F23, F32. F31, F32, F21, F23, F12, F12, and this F13. Then the resultant vector, how it will be? The resultant vector will be along the diagonal. यहाँ पे हमें resultant vector, the resultant vector will be along the diagonal. And discharges and the net force 0 and center of mass will be at rest. So Coulomb's law will obey the law of superposition principle. When 1 and 2 are interacting, the presence of third charge will not have any influence. This is one basic idea. Then what about all these forces magnitude? F12, F21, F13, F31, F23 equal to K Q square by L square. Then the resultant, we can say this angle will be how much? 30 degrees. 30 degrees. So the magnitude will be F1 equal to F2 equal to F3. This should be equal to how much? Should be equal to 2 F31 cos 30 degrees. F31, so this value will be L square root 3 by 2. This is the force acting on individual point charge. Similarly, यहाँ पे हम when 4 point charges are there, let me denote like this. This is 1, 2, this is 3, this is 4. These are the 4 point charges. Then how to calculate force on each point charge? F1, F12, F21. Similarly, F32, F23, F34, F43, F41, F14. Then we'll get the diagonal interaction. The diagonal interaction will be F13, F31, F24, F42. Okay, this is about the interactions. यहाँ पे हम indicate करेंगे. So this is F12, F14, F13. Similarly, यहाँ पे F21, F24, F23, F34, F31, F32, F41, F42, F43. Along the diagonal. This A angle कितना है? This will be 45. यहाँ पे हम वेक्टर लेके कौन सा तो एक फोर्स डिफाइन करेंगे F2. हर एक चार्ज का फोर्स सेम रहता है, मैग्नीट्यूड विल बी सेम, डायरेक्शंस विल बी डिफरेंट. सो इस तरह हम डिफाइन कर सकते हैं F21 I cap, F24 cos 45 degree I cap F24 then so substitute all the values will get it. यहाँ पे मैग्नीट्यूड इस तरह होगा F21 F23 देन सब्स्टिट्यूट हियर इसका वैल्यू F24 का वैल्यू कितना होगा F24 का वैल्यू विल बी KQ स्क्वायर L root 2 whole square. Fine. Huh? So this is about the so both सारे charges जब रहे तो then there is a method. Huh? You have to take the superposition then calculate the net force. The next one is electric field due to point charge. यहाँ पे हम point charge ले लेंगे. So the field due to the point charge is equal to E is equal to how much KQ by X square. It's a vector quantity. What is the direction? Direction इस तरफ होगा E bar. So यहाँ पे हम वेक्टर फॉर्म डिफाइन करेंगे and how E bar due to positive charge it will be away due to negative charge it will be towards how much magnitude will be KQ by X square. यहाँ पे हम चार्ज ले लेंगे I to define the E bar at this particular point at point P. इसका पोजीशन वेक्टर यहाँ पे हम डिफाइन करेंगे इसका पोजीशन वेक्टर इसका पोजीशन द पॉइंट P. We have to calculate the field at point P. यहाँ पे पॉइंट चार्ज यहाँ पे हम present है. Then how to calculate the this one position vector of A bar इसका A bar कर लेंगे. This is B bar, this is R bar. Then what is the magnitude? Magnitude तो E equal to KQ R square. Then E bar तो इस तरफ होगा equal to KQ square. So this will be KQ R square into R cap. यहाँ पे A bar plus R bar minus B bar equal 0. R bar equal to B bar minus A bar. यहाँ पे हम डिफाइन कर लेंगे इस तरह. So vector form R square. R cap will become R bar by R. So KQ R bar by R cube. KQ like this will define the electric field vector in the vector form. So suppose if you keep the point charge at Q, at point P how much of field? This is very important for JEE mains. Compulsory everyone must remember this basic method. What is A bar? A bar is a position vector where point charge is kept. What is the B bar? Position vector of point at which it has to be determined. This R bar has to be replaced because we know A bar and B bar. Okay kids, now the next topic will be lines of force. Then we know the electric field due to point charge E equal to, what is the basic formula? E equal to KQ by R square. Then what about the field? What is the electric field due to point charge? Electric field due to point charge is kq by r square. So जब आप what is the direction of E bar? The direction of E bar will be radially outward due to the positive point charge. Okay, fine. Due to negative point charge, it will be radially inward. Then यहाँ पे दो अलग चार्ज है, एक एक पॉजिटिवली चार्ज है and A be positively charged. The magnitude is different and number of lines of force. The number of lines of force are proportional to the number of lines of force are proportional to the magnitude of charge. अगर इसका magnitude ज़्यादा है बोलते then more number of lines of force we have to as well. This one. So यहाँ पे what is the information? Q1 greater than Q2. दोनों का like both like charges. The lines of force will be like this. Then यहाँ पे ज़्यादा दिख रहा है lines of force, यहाँ पे कम दिख रहा है. This shows that because number of lines of force is directly proportional to magnitude of charge. This is one basic idea. यहाँ पे हम दोनों चार्जेस सेम ले रहे then due to positive and negative like unlike charges and equal magnitude. So then यहाँ पे what is the condition will give it q1 equal to q2. Then now the lines of force will be like this. Then what are the lines of force? They are the imaginary things which we are drawing to express the electric field strength. To express the electric field strength due to point charge, imaginary lines. Sir, how many lines of force I can draw? Any number. But it should be proportional charge. For Q charge, if you're drawing 10, for 2Q, you should draw 20. For Q charge, if you are drawing 100, for 2Q, you should draw 200. And if you draw the tangent on the E, this one, if you draw a tangent here, it will give direction of E bar. If you draw a tangent, it will give direction of E bar. If you draw a tangent, it will give direction of E bar. If you draw a tangent, it will give direction of E bar. If you draw a tangent, it will give direction of E bar. If you draw a tangent, it will give direction of E bar. Therefore, if you release a point charge here, it will move along the lines of force. But if you release point charge here, it will not move along lines of force, it will move somewhere like this. So what are lines of force? Not like a path traced by the test charge. Need not be. So if you draw a tangent to lines of force, it will give E bar. The tangent drawn to the lines of force will give E bar. Okay, right? This is the basic idea. And then if there are 3 point charges, यहाँ पे 3 point charge है. यहाँ पे मैं indicate कर रहा हूँ. A तो हुआ positive charge, this one negative charge, and this one is positive charge. Okay, fine. This will be, so the lines of force for 3 point charges will be like this. यहाँ पे positive charge है, negative charge, positive charge, negative charge. And then यहाँ पे देख लो like lines of force. Positive charge, the lines of force will originate from positive charge, will terminate at negative charge. आप कौन सा भी ले लेंगे अगर प्लस क्यू -2q plus 3q, you can draw lines of force. रफ डायग्राम इस तरह आप लाइन्स ऑफ फोर्स को ओके फाइन। हाँ, कितना है लेके फॉर 3Q चार्ज कितना है यहाँ पे काउंट करेंगे 1 2 3 4 5 6 7 8 9 10 फॉर 2Q चार्ज को 3Q को 10 है, सो हम एक काम करेंगे इसका 9 ही करेंगे। थ्री थ्री नाइन 2Q का चार्ज कितना 6 लाइन्स, यहाँ पे 6 लाइन्स ऑफ फोर्स चाहिए। इसके लिए ओनली 3 लाइन्स ऑफ फोर्स। ओके, थोड़ा आइडिया आ रहा है आपको? सो दिस विल बी पॉजिटिव चार्ज, एरोस इस तरह दिखा दीजिए आप। You can draw any number of lines of force. So like आप 3Q को 9Q ले रहे हैं, so you can take 90 here. अगर ये आप 90 लेंगे, then यहाँ पे कितना 60, यहाँ पे 30 lines. Patience है तो draw करियो, draw करो, no issues. In exams, choose less number of lines of force. Roughly you should estimate it. And if you draw a tangent here, you give the direction of V bar. This is one basic general idea of the lines of force. Okay, now we have the electric field due to charged bodies. Charged bodies. What do you mean by charged bodies? Ring, rod, disc, sheet, sphere. So कैसे प्रिपेयर करते हैं हम चार्ज बॉडी? सो ये रिंग प्लास्टिक का बैंगल, कौन सा तो प्लास्टिक रिंग ले लो, वहाँ पे यूनिफॉर्म चार्ज डिस्ट्रीब्यूशन करते हैं हम। मीन्स द चार्ज विल बी डिस्ट्रीब्यूटेड यूनिफॉर्मली, देन इट बिकम ए चार्ज। ऑल दिस आर नॉट लाइक ए कॉटन थ्रेड, प्लास्टिक, ग्लास रिंग, उसके ऊपर हम यूनिफॉर्मली चार्ज डिस्ट्रीब्यूट करते हैं, देन इट बिकम ए यूनिफॉर्मली चार्ज रिंग, इट हैविंग रेडियस ए, इट ए डिस्टेंस x। यहाँ पे इलेक्ट्रिक फील्ड ऑन द एक्सिस गिवन बाय q x 4π0 x square plus a square to the power of 3/2। वेरी इंपॉर्टेंट फॉर्मूला, यू हैव टू रिमेंबर k q x by a square x square to the power of 3/2, एंड इसका डायरेक्शन इस तरफ होगा along the axis। At the center कितना है? At the center it will be 0. Put x equals 0, it will be 0। and इसका आप जब ग्राफ प्लॉट करेंगे, it will be like this, maximum at r by root 2। so शायद सभी को पता होगा। so this is very very important। maximum problems are there on this E bar due to charger ring। then similarly E bar due to charged disk। डिस्क बोले तो यहाँ पे लगे सिग्मा विल डिफाइन इट। यहाँ पे हम सिग्मा डिफाइन करते हैं, E इक्वल टू सिग्मा इक्वल टू क्यू बाई पाई आर स्क्वायर, चार्ज डेंसिटी, चार्ज बाई एरिया। देन ऑन द एक्सिस इसका इलेक्ट्रिक फील्ड कितना है, देन दिस गिवन बाय 2πk। सो इसका फर्दर यहाँ पे हम एक काम करेंगे। सो दिस विल बिकम E इक्वल टू k विल बी 4π0, so this will become sigma by 2ε0 1 minus z equal to z square r square। okay, there is electric field on the axis। electric field at the center O, it will be sigma by 2ε0। it's undefined, undefined। okay, like this, the electric field strength on the charged disk at a distance z from the axis, this is the axis given by this formula। then We'll take the next E bar. E bar on the axis. So there's a charge on the rod, E due to finite rod. इसका चार्ज कितना है, लैम्डा है. Then what is the length? यहाँ पे इलेक्ट्रिक फील्ड डिफाइन करना है. सो व्हाट इज द मैग्नीट्यूड ऑफ इलेक्ट्रिक फील्ड ड्यू टू लॉन्ग रॉड. इसका फॉर्मूला अगर याद है तो ओके फाइन, अदरवाइज आपको डिराइव करना पड़ता है इन एग्जाम. वेरी वेरी इंपॉर्टेंट. इलेक्ट्रोस्टैटिक्स, इलेक्ट्रिक फील्ड एंड पोटेंशियल. What is the formula? What is A the distance from one end. At point P we have to calculate. इसका electric field given by K. This will be K lambda L by A into A plus L. This electric field at this particular point due to finite charged rod. E due to long charged rod. What is the direction of E bar? यहाँ पे E bar इस तरफ, इसका direction lambda 2 pi epsilon naught r. This electric field. अगर this is a charged rod, इसका E bar direction will be radially outward. इस तरह होगा. This direction of lines of force very important. Fine. E due to long charged rod. This is the formula. E due to semi-infinite charged rod. यहाँ पे two components होगा. एक perpendicular component. Other will be parallel component. Then what is the magnitude of these two? E perpendicular, E parallel will be lambda by 4 pi epsilon naught d. Then resultant magnetic field EP. So this will be resultant of these two. Both will have same angle 45. So what is EP is equal to E perpendicular square E parallel square will be root 2 E perpendicular lambda by 2 root 2 pi epsilon naught d. इसका combination. So there's a E bar due to semi-infinite charged rod. हम थोड़ा examples भी ले लेंगे. अगर if there is a no, if there is a semi-infinite rod like this, there is a semi-infinite rod. यहाँ पे दो सा. What about the magnetic field, electric field at these points? इसका charge density lambda, इसका भी lambda है. यहाँ पे हमें फील्ड कैलकुलेट करना है. इसको हम 1 डिनोट करेंगे, 2 करेंगे. यहाँ पे फील्ड्स आई इंडिकेट लाइक दिस. E1 perpendicular, E1 parallel, E2 perpendicular, E2 parallel. यहाँ पे नेट फील्ड 0 होगा. इसका मैग्नीट्यूड, इन सभी का मैग्नीट्यूड कितना है? E1 perpendicular, E2 perpendicular, E1 parallel, E2 parallel. इन सभी का मैग्नीट्यूड will be lambda by 4 pi epsilon naught d. The net field at point P will be 0. Both these are semi-infinite charged rods. Like this, you'll get some application questions. You have to be careful. मेरा वीडियोस चेक कर लीजिए. एक 4-5 best questions are there based on this combinations. That will really help you. अगला वन, नेक्स्ट वन इज ई ड्यू टू आर्क, चार्जड आर्क. यहाँ पे आर्क है, इसका चार्ज डेंसिटी लैम्डा, इसका रेडियस आर, यहाँ पे radius is r. Now we have to calculate the field strength at this point O. So what is the field strength at point O? It will be equal to EO. This is given by lambda into lambda by 2 pi f naught r into sine of alpha by 2. What is alpha? Angle subtended by the arc. And lambda by 2 pi f naught is something related to line charge. E due to long rod into sine of alpha by 2. इस तरह आप रिमेंबर कर लो, इट विल बी वेरी इजी फॉर यू. सेमी सर्कल यहाँ पे मॉडिफाई करेंगे. इफ दिस इज द सेमी सर्कल, अगर ये सेमी सर्कल रहे तो देन what is the E field strength at this point? Lambda by 2 pi f naught r. Alpha, what is alpha? Alpha will be pi, sine pi by 2. ये तो 1 हुआ, so the total will be 2 pi epsilon naught r. अगर क्वार्टर सर्कुलर आर्क रहे तो then what will happen? And the field strength at this point will be EO. अल्फा, इसका एंगल अल्फा कितना हुआ? पाई बाई 2. Pi by 2 by 2 will be pi by 4. So lambda by 2 root 2 pi epsilon naught r. यहाँ पे E due to R का quarter circular arc, semicircular arc. So there's a basic formula you have to remember. Very, very, very important for JEE mains. Okay, now we have the E due to solid hemisphere. At the center, it is having radius how much? Radius is equal to capital R. Then the charge density. So then what is the electric field strength at the center O? Will be rho r by 4 epsilon naught. Similarly, E due to hemispherical shell, charge will present only on the surface. We define this as sigma. Charge density here is like a half watermelon. This will be like a half shell. Then surface charge density will come. Then the electric field at the center O is defined as sigma by 4 epsilon naught. Very important in exam. You can't derive all this. You have to remember. Then electric field due to charges sheet, either E positively charges sheet given by sigma by 2 epsilon naught. If there are two sheets are there, due to positive sheet, due to there's a sheet 2, you can see this one, there's a sheet 1, it's a positively charged, the field will be away. Then due to negatively charged sheet, the field will be towards. Then if both the sheets are kept here in this region, due to sheet 1 and due to sheet 2 will get added up here. Fine. Next, due to sheet 1 it will be in this direction, due to sheet 2 it will be in this direction, so we'll cancel out. So here we'll get like this, 0, this will be 0. Here it will be sigma by 2 epsilon naught will be sigma by epsilon naught. Why it is 0? Because they are opposite, no, here the field. Like this we can discuss the superposition also due to charged bodies. We take the next. Next we have the E bar due to uniformly charged sphere. This is a charged sphere having charge q. Then what is the electric field outside? Outside it is P given by kq by r square. On the surface is given by kq by r square. Inside kqr by r cube. And there's a point B, I'll write it, or somewhere at a point inside. There's a uniformly charged sphere. So what is the field strength? Field strength inside will be this much, or we can also write it as rho r by 3 epsilon naught. These are the different formulas which you have to remember. Electric field inside uniformly charged sphere. Inside at center will be 0, and as you move the field strength will increase. On the surface maximum, then outside it decreases. Okay, fine. Now similarly we'll calculate the electric field in a uniformly charged sphere. There's a cavity here. Then this having a density rho. There's a sphere of radius. Then electric field due to this will be here in this direction. Due to cavity, it will be in this direction. Then the resultant will be in this direction. Resultant दूसरा ले लेता हूँ. What is this? Due to sphere, it will be E1 bar. Due to cavity, E2 bar. And the resultant E bar. So what is the electric field inside E bar? E bar should be equal to, or vector form में लिख देता हूँ, E1 bar plus E2 bar minus E bar equal to 0. E bar equal to E1 bar plus E2 bar. E1 bar rho R1 bar by 3 epsilon naught. This will be rho R2 bar by 3 epsilon naught. What is R1 bar? This vector. R2 bar, this vector. Then here we are having like this. This R1 bar, R2 bar, and this R bar. So this will become rho 3 epsilon naught R1 bar plus R2 bar. R1 bar plus R2 bar, that should be equal to the distance between the cavities, center of the sphere and the cavity. Okay, sir, why you are taking this E bar radially outward? For positive charge radially outward. For cavity, what happens? We have to treat it like a negative charge and it will be directed towards center. So E1 bar plus E2 bar will be E bar. And this will be in the vector form. Next we have the F equal to QE problems. There is an uniform electric field E bar is present. I'll release a charge particle, say Q1. According to the formula, E bar equal to F bar by Q. So this F bar we can write it as Q into E bar. Plenty of good application problems. Just you have to remember this formula only. Then if a positive charge is released in electric field, then the positive charge will experience force in the direction of electric field. Then definitely due to this it will accelerate. Due to this it will accelerate. And due to acceleration it will reach here. There's a velocity. Fine. Okay, agree this. Similarly, what is the time it will take? So can we calculate velocity? As velocity will be calculated by the formula v1 is equal to a1t. What is a1? q1 e by mt. T is the time taken and x is the distance. At t equals 0, if it is here, it will come after some time t, it will be here. Similarly, if a negative charge particle is released, what will happen to it? It will experience force opposite to electrostatic field, and because of this force, it will accelerate. And when it reaches here, it will have some velocity. The same method again. What is v2 equal to? v2 equal to a2t. This will be q2 em into t. This is speed. Like this, we can calculate the speed of the particle. Then, if you project a charge particle like this with the velocity 1, the force acting will be F1. Then the charge particle will move like this parabolic path. Then when it arrives here, it will have velocity Vx and Vy. The force will be continuously will be acting. It's a discrete parabolic path. Okay, I agree this. So then what we can write here now, like a acceleration along x-axis qe by m. We will write q. Then Vx equal to ax into t. So qet by m. Vy equal to Vy, there is no acceleration along y-axis. Vy will be uy. It's going to describe a parabolic path. If a negative charge particle is projected, let's assume that a negative charge particle, how do it will move? Then it will experience a force in this direction. Then it will move like this. Agreed? So this is about the force in like a charge projected in a electric field. Okay, sir, like if it is if this is the electric field, if this is electric field, we'll take other one more condition. If you project with a velocity somewhere at an angle, what to do? Then it will have ux and uy. Force also will act. Fe. Then how do it will move? It will move again in parabolic path. Again it will move in a parabolic path here. Okay, agree this. Like this we are having the basic ideas. And this is very important, something related to projectile, the questions will be asked. Let me discuss some basic ideas. Suppose say like there is a यहाँ पे हम एक चार्ज प्रोजेक्ट करेंगे and this is the electric field and gravity weight mg and electrostatic force also will act. Then now the charge particle will move in a parabolic path. Then there's a maximum height. Then we'll get the range. The same concepts. Only thing is now the vertical acceleration ay is equal to qe plus mg by m, which will be qe by m plus g. The charge particle here will have velocity like this. Okay, fine. So this will be the range. Then what about the time of flight? Time of flight depends only on vertical component, 2u sine theta by g. And what is the range equal to? Ux into t. Yes, even the electrostatic field will also determine the range and maximum height ascended. Then we'll take some other concepts like pulley constraints में there's a block Q1, चार्ज Q2, इसका वेट कितना M2G, यहाँ पे M1G. Now if there's an uniform electric field, then how electrostatic force? Here Q2E, Q1E, N1, here N2, there's a tension. Okay, fine, there's a positive charge. This is also a positive charge. Then it will accelerate like this. So इसका acceleration हो, यहाँ पे हम t plus q1 एंगल कितना थीटा, q1e cos theta equal to m1e, m2g minus t minus q2e sin theta equal to m2a. Solve it, we'll get tension and acceleration. Any charge particle in electric field will experience force. और एक यहाँ पे inclined plane का ले लेंगे. If there's an inclined plane, if any charge particle is kept and there's a uniform electric field is present, how it will experience force? QE. This surface is rough. Then forces acting mg sin theta, normal contact, mg cos theta, यहाँ पे friction. This electrostatic force is due to what? Like due to charge present in electric field. That's all. Remaining all things you know it. Like this, electrostatic force can act with friction, can act with the gravity, can act with the tension. और एक examples दे देता हूँ. Suppose we have there's a spring, gravity. I'll switch on the uniform electric field. यहाँ पे weight, electrostatic force QE, then spring force Kx naught. So what is Kx naught equal to now? QE plus mg. हर जगह आप जहाँ पे भी charge particle is there in electric field, there what happens? The charge in electric field will become electrostatic force. And the moment you see charge particle in electric field, the electrostatic force will be acting. Okay, fine. Then we'll take some two pendulums suspended one. And they are suspended from same point. यहाँ पे एक charge है. इसका charge Q1, Q2. Weight M1G. Weight M2G. Tension T1. यहाँ पे tension T2. Theta 1, theta 2. Electrostatic force Fe. Okay, like this we'll get the forces. At equilibrium we can balance this one. T1 sin theta 1 minus M1G equal to 0. Sorry, T1 cos theta 1. T1 sin theta 1 will balance electrostatic force. So tan theta 1 is equal to how much? Fe by m1g. What is Fe? Q1e by m1g. Similarly, tan theta 2 is equal to Q2e by m1g. Fe no not Q here. इसका अलग है, फॉर्मूला अलग है. Fe means electrostatic force. K Q1 Q2 by this length you call R square m1g. Tan theta 2 will be Fe by m2g. डायरेक्टली यहाँ पे लिख देता हूँ K Q1 Q2 by R square m2g. Two charged particles suspended from common points. So there's one basic method. All these are related to like a F equal to QE applications. Then next we'll take the Q. यहाँ पे स्प्रिंग है. Then there's a electrostatic force will be acting. No, I'll disturb this. We will discuss the oscillations of a charge. What is the topic? Topic name is oscillations of a charge. So I will slightly disturb this particular point charge. It is being disturbed. You can see it earlier, it was here. Now how much it is being disturbed? By distance x. Then how much this length will be? L minus x. Then what are the forces that will be acting? Here call F3. F31 like this. F32. Then what is the net acceleration? Net acceleration Fa equal to F32 minus F31. F32 will be K Q naught Q by L plus X whole square. This will be K Q naught Q L minus X whole square. This will be K Q naught Q L square minus X square whole square. Simplification directly I am कर रहा हूँ. I don't have time. So this will become Ma is equal to 4K Q naught Q L X so time period is 2 pi ml cube by 4K Q naught Q. If the middle one, if you slightly disturb, it will be oscillating. The middle one will be oscillating. Here it is at center midpoint at equilibrium. So slightly displaced will be oscillating. This is like oscillations of charge. Like this, we'll get some problems with SHM also. You have to be careful. Next again, some Bayron point charges. Point charges kept on the rough ground. दिस सरफेस इज रफ, देन यहाँ पे इलेक्ट्रोस्टैटिक फोर्स इस तरफ होगा, देन फ्रिक्शन इस तरफ, this is a normal contact, this will be M1G. You can bring even the friction also. When 2 point charges, if they are kept on rough surface, the electrostatic force will be balanced by friction. Then what is the maximum separation between the charges so that the system can be in equilibrium? Then for इसके लिए हम क्या करेंगे, like a F E equal to F, then K Q1 Q2 x square equal to mu, इसका मास सेम लेंगे, then it will be easy, mu mg, then we'll get x value k q1 q2 by mu mg. If the separation becomes less than this, then it will not be in equilibrium, then greater than this it will be in equilibrium. Now there's a very generalized thinking which you have to develop now. I have the charge particle which is going to revolve around the line charge. Let me choose a negative charge particle. Then there's a rod, charged rod, there's a point charge. So the charge particle will revolve around the line charge. So then what is the expression for the time period? So then we will provide required electrostatic force Fe. So Fe is equal to mv square by r. This is K charge Q into E m omega square r. What is equal to? Lambda by 2 pi f naught r m omega square r. Solving for omega will get the required answer. Q lambda m 2 pi m epsilon naught r square. Then t equal to 2 pi by omega. So charge particle revolving around a line charge. Then what is the time period of this particular point charge? Like this, see, like this electrostatics now will come in almost in all the topics. Just only charge particle in an electrostatic field will experience electrostatic force. So from where this Fe will come, the electrostatic field E bar will be like this. Negative charge will experience electric field opposite to, force opposite to electric field. Electric field due to line charge will be away from it. So negative point charge will experience force towards it, opposite to E bar. Next we have the interaction electrostatic potential energy. If there are 2 point charges are there, Q1 and Q2, separated by R, both are positive charge. Interaction potential is K Q1 Q2 by R. If one is positive, other one is negative, the interaction potential is K Q1 minus Q2 by R. Fine. So if like charges, interaction potential will be positive. Unlike charges, it will be negative. We take the, if there are 3 point charges are there, Q1, Q2 minus Q3. A, B and C. The interaction will be U12, U13 plus U23. U12, K, Q1, Q2, A. U13, K, Q1, this will be minus no, Q3 by B. Between 2 and 3 will be minus K, Q2, Q3 by C. If there are 4 point charges are there, Q1, we'll take like this, plus Q, minus Q, minus 2Q, plus 3Q. Then what is interaction potential? 1, 2, 3, 4. The interaction potential will be 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 plus 3, 4. 1 and 2 will interact. 1 and 3 will interact. 1 and 4 will interact. 2 and 3 will interact. 2 and 4 will interact. 3 and 1 will interact. 3 and 4 will interact. So 6 interactions. Then substitute this. This will become U12 will be minus k q square L. U13 will be minus 2k q square L root 2. U14 will be 3kq square L. U23 will be 2kq square L. U24 will be minus 3kq square L root 2. U34 will be solve it till get. If interaction potential G, if it is positive, system will expand. If it is negative, system collapses, contracts. And this is about the 3, 4, wherever they will, like it just depends on the separation between them. Next, we'll discuss the electric potential. It's a scalar quantity. It's a scalar quantity. The symbol is what? V, and it's a scalar. Then electric field potential due to the ring, and the ring it will be kq by root of a square plus x square. Potential at point 2, at the center of the ring it will be kq by e. Then potential at point P due to charged disk, there is a charged disk. It is given by sigma, charge density, sigma by 2 epsilon naught r square plus x square minus x. Then potential at the center, sigma r by 2 epsilon naught. Potential on the rim, sigma r by pi epsilon naught. This is on rim. This is at center. And this is on axis. Charge density, the charge will be present on one surface. There is a thin charged disk. Next, similarly, we'll take the potential due to shell, hemispherical shell. Potential due to thin hemispherical shell. This will become equal to V naught at the center. This will be equal to sigma r by 2 epsilon naught. इसको यहाँ at the center यहाँ पे कितना potential है sigma r by 2 epsilon. Charge only on the surface it will be there. Next we'll go for V due to solid hemisphere. Due to solid hemisphere at the center it will be V naught is equal to rho r square by 4 epsilon naught. यहाँ पे this is a half charge sphere. What is the solid hemisphere? It is also like a R. Then potential on the surface of the cone. Charge will present only on the surface. Then potential is given by Q by 2 pi epsilon naught L. What is L? L is the slant length. यहाँ पे what do you mean by slant length? This is the slant length. In terms of this it is given. Just like in exams को आपको ये याद रहना चाहिए. इससे आप easily कौन सा भी problem नहीं दो, you can manage it. Next इसके बाद में V due to arc के वजह से. Then what is the field at this particular point? It is equal to V naught equal to कौन सा भी charge ले लो, it will be at a distance r, no? So this will become k q by r, because you take any point on this arc will be at a distance r only. Okay, fine. So potential due to arc. Next, potential due to long rod. This is a uniformly charged rod at a distance x. So we'll calculate the field at this particular point. What is the field? Lambda by 2 pi epsilon naught x. Then let this be dx. Then dv is equal to minus of e bar dot dx, v1, v2, x1 and x2. So this will become v2 minus v1 minus v2. Negative sign will come on this side. Angle between e bar and dx, it is 0 degree. You can check it, the angle dx and e bar same direction. Then this will be x1 to x2. So this will become v1 minus v2, x1 to x2, lambda by 2 pi epsilon naught x dx. So v1 minus v2 will be lambda by 2 pi epsilon naught dx by x, x1 to x2. If x1, x2 is at we wanted potential at this point P1. Then how to manage this one? There's a log of x2 by x1. So we'll make x2 as infinity, far away. So only we can tell the potential difference. We can't tell anything like exactly potential. The potential difference between 2 points. So what is x1 and x2? Here this is x1 and this is a point 2. The potential difference between these 2 points we can tell using this particular formula. Due to long rod, this some small idea you should remember. Next we have the E equal to dou V by dou X and work done in E bar, work done in moving a charge in electric field. First, if you know the potential, suppose a potential equal to ax square plus by plus cz cube, then the x component is given by minus dv by dx. Differentiating this, I'll get x component which is equal to minus 2ax I cap. You have to differentiate the function with respect to x. Similarly, if you want y component, minus dv by dy j cap. Differentiating this will be minus b j cap. Ez equal to minus dv by dz. Differentiate with respect to z will be 3c z square k cap. The net field will be ex bar ey bar plus ez bar. Similarly, if you are having a function a or x square x y cube z square, then what about this one? Differentiating with respect to x, ex will be minus dv by dx ey magnitude will be minus dv by dy will be x3y square z square. Ez equal to minus dv by dz will be x y cube 2z. Any function, if you know the potential, differentiate, we'll get the electric field. This is one simple thing. Then similarly, if you know the electric field, can you calculate the potential? This is something very important. The basic formula will be dV bar dV by dr. So dV equal to minus of E bar dot dr bar. Keep it like this. Your different A and B. So VA, VB. So this will become VA minus VB equal to integral of E bar dot dr bar A to B. This is one generalized formula. Try to remember. Any field if you have, you can so suppose say E bar is 2I cap plus 3J cap. Point A is 1 comma 2, B is 0 comma or 3 comma minus 2. I want potential difference. That is substitute VAB equal to 1 comma 2, 3 comma minus 2, 2I cap 3J cap dot dr bar dx I cap dy j cap. This will become 2 integral of dx 1 to 3, 3 integral of dy 2 to minus 2, 3 minus 1 minus 2 minus 2, 4 minus 12 minus 8. This will be in volt. Like this you can find out the potential difference. If you know the electric field. Now if there is a variable electric field is there. Let me take the other one. If there is a variable electric field is there. E bar equal to then work done, potential difference between these points, VAB. Then what is the formula? VAB equal to minus A to B E bar dot dr bar. So 2x square y I cap j cap. So then this will become VAB. This negative sign will not be there. Already we have adjusted, no? Then this will become 2 x square y dx plus this will be x y square z dy limit will be no. So that's same limit will be 0 comma 0 to 1 comma 2 comma 1. Now where we are at 0 comma 0. First I'll move along x axis. What is the value of y? Y will be 0. So 2y x square dx. So this will be 0 to 1, but the value of y will be 0. Then I'll now where I am at 1 comma 0 comma 0 x z outside y square dy. This will be 0 to 2, and I'll make it 3. It will be easy for us to understand things. Now what is the value of x? X will be 1. What is the value of z? Will be 0. Then this will be next plus x y integral of z dz. This will be 0 to 3. Value of x will be 1. and this will be 2. Now if you look at this quantity, in place of y it will be 0, in place of z it will be 0, in place of x it will be 1, in place of y it will be 2. The next step will be VAB is equal to 2 into 0 integral of x squared dx. This will be 0 only. 1 into this will be 0 integral of y squared dy, 0 to 2. This will be 1, 2, z square by 2, 0 to 3. 0 plus 0, 2 get cancels. This will be 3 square. This will be 9 volt. So what is the potential difference? 9 volt. Like this, if they give electric field, you can calculate the potential difference. If they give the potential, you can calculate the electric field. Refer my videos, plenty of problems are there. There's a basic idea I'm giving. Okay, next again, what is the use of this? Work done. So we can also calculate the work done. Suppose say this is the formula. dV is equal to minus E bar dot dr bar. VA, VB, A to B. This will become VA minus VB equal to integral of E bar dot dr bar. I'll multiply charge on both sides. This will become Q VA minus VB Q E bar dot dr bar. This will become work done in moving a charge from A to B, which is equal to Q into potential difference. So therefore, work done by electrostatic force in moving a charge from A to B should be equal to Q into VA minus VB. Work done by external agent in moving a charge from A to B will be VB minus VA. There's a formula to try to remember, very useful for you. Then we have the equipotential surfaces. For a point charge, the equipotential surfaces will be spherical. Why they'll be spherical? Because how the E bar will be? E bar will be radially outward, no? For a point charge. E bar will be radially outward. Then this will be some potentials we'll write like this. 60 volt, 70 volt, 40 volt, 50 volt, 40 volt. Then the electric field vector will be directed from higher to lower potential. And all this surface will be an equipotential. So for a point charge, the equipotentials will be spherical. And what is the basic idea? Equipotential surface will be always perpendicular to E bar. This is a basic idea. In a uniform electric field, suppose that there is a uniform electric field is there. How the equipotential surface? The equipotential surfaces will be normal to the line. Then this will be say some 60 volt, 45 volt, 20 volt like this. And the E bar will be directed from higher to lower potential. So when this is a separation delta X, then what is the potential difference between point 192? Delta V is equal to E into delta X, or which is V1 minus V2 equal to E into delta X. In equipotential, in an uniform electric field, the potential difference must be equal to electric field into distance measured in the direction of field. This is something very important. If the separation equal to D, then what is the potential difference? E into D. This is what we'll be using in coming chapters, current density, capacitors, in other application problems. Okay, this is one basic idea, equipotential surfaces. Okay, kids, the last one here, like we have the electric dipole. So this electric dipole is nothing but the it's an atom only. What is this plus q? Plus q is the nucleus of the atom, and minus q is the revolving charges. The revolving electrons is minus q. So what can be the separation between electrons and the nucleus in atom? Very small. So practically, if you see this R will be very, very small. Practically, this R will be very small. R will be, or select R will be very much greater than L. Then we'll define one quantity called as a dipole moment. What is the dipole moment? 2L into Q. It's a vector quantity. It will be directed from negative to positive charge. This is called like a dipole moment. Then we have to calculate the field and potential. All the formulas are there. At point A, potential is given by K P cos theta by R square. The potential. So here we have two components. One parallel component, other will be perpendicular. The resultant will be this direction. So what is E parallel? E parallel is given by minus dV by dr, radial one. Differentiating this, 2 kp cos theta by r cube. Perpendicular component is given by 1 by r dV by dt, which is equal to kp sin theta by r cube. The resultant field is given by root of E perpendicular square, E parallel square. Now this is called like a axis of dipole. This is called like a bisector. So what is the field on the axis? What is the field at this point? E2. The resultant field at A, it is given by K P by R cube 3 cos square theta plus 1 and it will make some angle. This tan phi is given by E perpendicular by E parallel, tan theta by 2. Okay, this is about the angle made by the resultant E bar with the position vector. Then on the axis, how much? This is called like the electric field strength on the axis. This axis. So what is E1? Like we'll do one thing. What is cos theta? Theta will be 0. Then it will be 2kp by r cube. The field, how much it will be? On the bisector. Okay, this is E1 or field on the axis. On the bisector. On the bisector, it will be in this direction. How much it will be? Put theta 90 degree. This will become only kp by y cube. This is x. This distance we'll call y. Similarly, potential on the axis. Potential on the axis will be cos theta will be 0. Cos theta will be kp by r square or x square. Then on the bisector, cos 90 will be 0, will be 0. Like this, we'll get the potentials. Okay, this is about the field due to dipole. Dipole is nothing but like a atom only. The field produced by the polarized atom. Where do we can see this electric dipole moment? in substance which will get polarized. Then this idea of the atom will behave like a dipole, this concept is needed. Okay, then if this dipole kept in an, if two dipole kept in an electric field. Next, if a dipole is kept, okay, first I'll keep the dipole like this, negative charge, positive charge. There is a uniform electric field. Then the positive charge will experience force in the direction of field. Negative charge will experience opposite to it. And this will be minus Q plus Q. Net force will be 0. The net force on the dipole will be 0. Similarly, if a dipole is kept so that positive charge on this side, negative charge, we'll see what about the force. Now the force on the positive charge will be like this, negative charge will be like this. So now also net force will be 0. Now if the dipole is kept perpendicular in this order, then how the force will be? Then the force, positive charge will experience force in the direction of it, negative charge in this direction. What should be the net force? Net force again it will be 0. So in all three cases, the dipole, the net force on the dipole will be 0. If a dipole is kept in an uniform electric field, the net force will be 0. If the dipole is kept in the non-uniform electric field, non-uniform electric field will produce point charge. Something like this will take it. Now here I'll keep a dipole. Positive charge will experience force F plus, negative charge F minus, F plus greater than F minus. Net force will be in this direction. Now if the dipole is like this, positive charge will experience force like this, negative charge will experience force like this, and still F plus sorry, F minus greater than here, sorry, like so still F minus, so the net force will be again will be non-zero, so the force on this will be non-zero and it will act somewhere like this. So what is the basic idea? Like if a dipole is kept in an non-uniform electric field produced by the point charge or the line charge, the net force will be non-zero. We'll discuss also the torque. Torque due to dipole moment is given by P bar cross E bar. Then interaction potential between the dipole and the electric field is given by this particular formula. This is a torque, and this is about the potential energy of a dipole. Then what about the torque on the first dipole? Will be 0. Torque on second dipole will be 0. You can see a net torque, net force 0. What about torque here? Torque here will be non-zero because the dipole will swing like this. The dipole here will experience a net torque. So torque here will be non-zero. Similarly, torque on the first dipole will be 0. Torque on second dipole will be non-zero. Like this, if a dipole is kept in a uniform or non-uniform, we can discuss the torque. Torque is given by this particular formula. We'll take the oscillations of dipole. If I have the uniform electric field, there's a uniform electric field is there. There's a dipole. Now I'll slightly displace it. When I slightly displace it, oscillations of dipole, this will experience force F plus, F minus. It will set up torque about this point. Q, this will be Q. So the net torque will be torque equal to P bar cross E bar. So this will be P E sine theta. Dipole, each point charge will have a mass M. So they'll have a charge Q. Then what is the torque equal to will be I alpha. Why I alpha? Because it is given angular displacement theta like this. I'll expand the diagram. This is a fixed term. Then now the torque is acting in this direction. So therefore, that's why the theta and the alpha torque are opposite action. That's why this particular negative sign. Then this should become equal to minus 2ml square alpha, dipole moment 2lq e into sine theta, alpha equal to QE theta by ml. This is the time period of oscillations of dipole in an uniform electric field. Okay, next afterwards, force of interaction. If there are two dipoles are there, there's a dipole P1, there's a dipole P2. What is the force of interaction between them? Then we'll assume that dipole interaction between them U is equal to minus P2 bar dot E1 bar. Or we'll assume that this dipole is present in the field of this one. So therefore now, this dipole is present on the axis of this dipole. So therefore, what is the field here will be? The field here produced will be E1 bar will be in this direction. What is the angle between them? 0 degrees. So therefore, this will become U equal to minus P2 E1 cos 0 degree. E1 equal to K P1 by X cube. U equal to K P1 P2 X cube. We'll differentiate this. Du by dx is equal to plus 3 K P1 P2 x to power of 4. Then F equal to minus du by dx. So this will become minus 3K P1 P2 by x to power of 4. So this force will be proportional to x to power of 4. So when a dipole 1 is present in the field of dipole 2, when it is present in the field of second dipole. The second dipole is present in the field of first dipole. Then what is the force of interaction? It will be like this. Means when the dipole moments are when second dipole present in the field of on the axis of first dipole, the force of interaction, there is a formula you have to remember. Similarly, if second dipole is present on the bisector of other dipole, Then how do this will come like this? If there's a one dipole, the other dipole here, the other dipole is present like this. Its dipole moment is P2. Its dipole moment is P1. This is Y. Then how the electric field vector here, due to first dipole, it will be E1. We'll just represent this as one dipole. This is our second dipole. Okay, fine. Now what is the formula again? U equal to minus P2 dot E1 cos 180. Why cos 180? What is E1? Field due to first dipole here. So this should become equal to U equal to P2. What is E1? K P1 YQ du by dy equal to minus 3 K P1 P2 by y to power of 4. So F equal to minus du by dy 3K P1 P2 y to power of 4. There's a force of interaction when there's a bisector of first dipole. Previous it was 6, check it. Oh, the field I got better. This is 2 is missing here. On the bisect will be 2, no? It will become 6. Very important. On the bisector, the field will be 2K P1 x cube. Okay, there's a force of interaction formula, very important, you are supposed to remember. This is about the force due to dipole, force of interaction between the dipoles. Okay, kids, like this is about the basic electrostatics. यहाँ पे हम इट्स वेरी लेंदी, सो आप जब एग्जाम अभी 10 दिन या 5 दिन है, यू कांट डिराइव ऑल दिस थिंग्स. सो व्हाट इज द स्ट्रेटजी यहाँ पे, लाइक इलेक्ट्रोस्टैटिक्स? पहले आप एक काम करो, लाइक इलेक्ट्रिक फील्ड एंड पोटेंशियल ड्यू टू ऑल द चार्ज बॉडीज, एक चार्ट बना लो एंड मेमोराइज कर लो. वो इलेक्ट्रिक फील्ड एंड पोटेंशियल आप जब उसको निकाल देंगे इलेक्ट्रोस्टैटिक्स से, बाकी बचे तो क्या है इलेक्ट्रोस्टैटिक्स, देन पॉइंट चार्जेस you can manage it, and F equal to QE, and they're all based on some sort of like mechanics related. Your electrostatics will become very 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 easy for you. So आपको electric field and potential due to all the charge bodies वो formula याद रहना चाहिए. The remaining what left over electric dipole, then F equal to QE and point charges का application problems, and they are related to mechanics. एक बार revise कर लो, then definitely you can manage very easily this particular topic. बच्चे क्या है कि लगे they will practice derivations, field due to disk. एग्जाम में कौन पूछता है derive electric field due to disk? कोई भी नहीं पूछता है. क्या पूछता है, लगे based on like a disk at distance 2r on the axis, find the ratio of electric field at 2r to 3r on the axis. फॉर्मूला में 3r 2r लगे तो आंसर आ जाता है. सो अगर आपको आंसर फॉर्मूला पता नहीं तो यू कांट मैनेज एंड यू कांट डिराइव इन एग्जाम. तो बच्चों लाइक यू शुड हैव द जस्ट बेसिक आइडिया किस तरह आता है वो फील्ड, जस्ट अ बेसिक आइडिया इंटीग्रेशन किस तरह है, देन ओके फिनिश, इमीडिएटली रिवाइज द फॉर्मूला. सो इलेक्ट्रोस्टैटिक्स द फंडामेंटल प्रिपरेशन इज field and potential. You must know due to all charge bodies. Remember this. Come back. The remaining all things are easier. And in dipole there are some formulas are there. Torque equal to P bar cross E. U equal to minus P bar dot E. Force of interaction between dipoles. Time period of oscillations of dipole. And electric field on the axis. Electric field on the bisector. ये formulas याद रख लो बस. This like this you should manage this electrostatics. Okay, please do understand topic first, learn, then remember all the formulas. Then afterwards you can solve the PYQ. Then if when you're solving PYQ, आपको वो benefit मिलेगा. Okay, बच्चों, like we will end up here. All the best. Do prepare nicely. Next video I'll upload on the Gauss law. Thank you all of you.